Hi all. So before moving on to our next topic of nernst equation, I thought let us better revise everything which we have studied because all these things will be useful in our nernst equation. So you should remember that we started our chapter with your electrolytic cell, right? We are still studying everything about your electrolytic cell. What is an electrolytic cell? Electrolytic cell is something which converts your chemical energy into electrical energy. That's what your electrochemical cell is. So then we studied the apparatus. The first apparatus which was just set up in a single test tube, that was not beneficial for us. Why it was not beneficial? Because we couldn't produce any electricity from it. Next, we studied about the apparatus. The apparatus, how does the electrolytic cell works? Galvanic cell. Zinc copper example we studied, and zinc is like we studied the apparatus, like the left hand side there is an oxidation reaction happening, the electrons are moving from anode to cathode. One trick I told you, learn about lone. Left side oxidation happens, left side is anode and it is negatively charged because electrons are getting stuck to it and it is moving from anode to your cathode. So electrons move from anode to cathode, but the electricity moves from cathode to anode. This was our apparatus setup, the reaction setups, Then we studied about something called a salt bridge. Why do we need salt bridge? To What is a salt bridge? Actually, it is an inverted U-shaped bridge which is filled with any inert electrolyte. We studied about the properties of electrolyte, and it is mixed with the agar-agar powder so that it become a semi-liquid thing. And why these salt bridges used? So that it can maintain the electrical neutrality and allow the flow of electrons, because you remember the left hand side you were getting a positive solution, the right hand side you were getting a negative solution. So because of this there was a liquid junction potential which was preventing the flow of electrons and thus preventing the electricity. That's why salt bridge was introduced, so that your inert electrolyte flows here and there and maintain the neutrality. This was all about your salt bridge. I think then we study the cell representation, how to write a cell reaction. That also we studied. Left side oxidation, like Zn2 plus, then a salt bridge comes in between, then whatever is happening in the reduction, and we write it like this, correct? Whenever the ions are present, that side we write the molarities also, 1m 2m, whatever molarity, not fixed. Then we studied, I guess, about your feasibility of the reaction. Before studying the feasibility, did we study anything? Let me check. Oh yeah, we studied about electrode potential. What is electrode potential? The charge separation between the metal and the electrolyte. That is your electrode potential. In electrode potential, we studied two things: oxidation electrode potential, reduction electrode potential. To avoid the confusion, IUPAC told let's just focus on standard reduction potential. If oxidation potential is given, just flip it out, flip the signs. Electrode potential also you can find it by E naught of cell. This is standard, this is fixed, and which is calculated as E naught of cathode minus of E naught of anode. And E of cell, which we'll be studying now, is calculated from Nernst equation, which we'll be studying in this lesson. Then we studied, I think, about your feasibility of the reaction. When the reaction is feasible, when your delta G value is negative or delta E is positive. So delta G is equals to minus NFE naught of cell. This is how you check the feasibility of the reaction. So in this particular lecture, we will be studying about Nernst equation. How do you find the electrode potential at different concentrations, different temperatures? That's what we are going to study. So the topic for this video is your Nernst equation. First, what will I do is I'll write what this equation is. There is no derivation as such, just remember this equation. E of cell, that is what we are going to find, right? E of cell is equal to E naught of cell minus of 2.303 NF, sorry, RT RT by NF log base 10 concentration of product upon concentration of reactant. E of cell, that's what your EMF of the cell is, right? This is your actual EMF of the cell at any concentration and temperature. At any concentration of temperature. E naught of cell is your standard at fixed concentration, right? 1 m, 1 bar, 180 m and 25 degrees Celsius. So this is your fixed EMF, standard EMF. EMF which is standard. R here is your gas constant. R is your gas constant and its value is 8 point, like this is a fixed value, right? 8.314 joules per mole Kelvin. This is your fixed value, 8.314 joules per mole Kelvin. T is your temperature, which is also measured in Kelvin. Temperature in Kelvin. N is your number of electrons which is transferred or gained or lost, whatever, number of electrons. F is your Faraday's constant. What was Faraday's constant? The charge on 1 mole of electron is called as Faraday's constant. This is your Faraday's constant. Faraday's constant, and this is 96,500 coulomb. P and R, these are the concentration of products and reactants. So this is how this, this is just a direct formula based topic. Nernst equation, this is how you find the E of cell. E naught cell minus 2.303 RT by NF log concentration of product by concentration of reactant. Now, if I put the value of my R, I'm putting the value of R. My temperature is also fixed, right? 298 Kelvin. And F. Like if I fix everything, like if I put the value 8.314, temperature is 298 Kelvin and my Faraday is 96500. If I do this thing, I will be getting a similar equation. E cell is equals to E naught cell minus of 0.059 by N. N is again your number of electrons log base 10 of concentration of product upon concentration of reactant. E of cell is equals to E naught cell minus of 0.059 by N log base 10 product by reactant. This, you should remember this, the first reaction also, but the second one is the most important. Like both are same, only second one is actually the derivation of the first one, but this is what you will use 99% of times. 99% of times you have to use this reaction. E of cell is equals to E naught cell minus of 0.059 by N log base 10 product by reactant. Now let's directly jump into the equations, jump into the questions, because you already know what is E of cell, how do we find the E naught of cell, right? E naught cell, E naught of cathode minus E naught of anode. That's why I was telling you in the last chapter, last videos, that you need to practice more on these type of questions. So let's start with the first question. The question is telling you, find the reduction potential and oxidation potential of. Whose oxidation potential you have to find? You have to find for this one. Fe2 plus 0.01 m. Fe, which is solid, at 25 degree. 25 degrees Celsius means 298 Kelvin. And what they have given is E naught of Fe2 plus and Fe. What is happening here? Reduction is happening, right? So this is reduction potential value, minus of 0.45 volt. So how do we find the reduction potential? What we can do is actually we can find either reduction potential or oxidation potential and just reverse the sign, right? Now since this is already given, let's try this thing. Let's find the reduction potential. So for reduction potential, we know the reaction will be Fe2 plus 2 electrons is giving me Fe, right? Now applying the formula, just directly write the formula first. What is the formula? E of cell equals to E naught of cell minus of 0.059 by n log base 10 concentration of product by concentration of reactant. One more thing, oh yeah, one important thing. Concentration of pure solids and liquids. Concentration of pure solids and liquids will be always be 1. You have to remember, concentration of pure solids and liquids will always be 1. So now just substitute the values. E naught of cell, it's already given to us. E naught of in the reduction potential, 0.45, right? So just substitute the values. 0.45 minus of 0.059. How many electrons are there? 2 electrons. 2 log base 10. The concentration of product. What is the product here? Fe. Fe is a pure solid, right? So it will be 1 divided by, what is the concentration of reactant? What is the concentration of Fe2 plus? 0.01 m, right? So just write it 0.01. Can I write 0.01 as 10 to the power minus 2? So I'll write it as 0.45 minus of 0.059 by 2 log base 10, 1 upon 10 to the power minus 2. If 10, this thing goes up, it becomes 10 to the power 2. So 0.45 minus of 0.059 by 2 log base 10, 10 to the power 2. Now how do you solve it? Like log base 10 raised to any number, this number will come in front, n log base 10, 10, this will be equal to 1. So now this one thing will be 0.45 minus of 0.059 by 2 into this 2 will come in front, 2 log 10. Log 10 is 1, so I'll directly write 1. This thing will cancel. You will get reduction potential as minus of 0.509 volt. This is your reduction potential, right? How do you find oxidation potential? Just reverse the sign. So oxidation potential value will be 0.509 volt. Just remember this question. Remember what all things are given in this question, because we'll again do a third question which will require all these values. So I'll just revise what we did. We need to find the reduction potential and oxidation potential of this thing given. Both things, both we need to find. You can find either oxidation potential also or reduction potential also. The reason why I'm finding reduction potential is because it will be much easier, because reduction potential value is being given. We know the formula. E is equals to E naught cell minus of 0.059 by n log base 10 product by reactant. This thing is already known to us, right? So just substitute all the values. 2. Why 2? Because 2 is the number of electrons here. Log base 10. 1. Why 1? Because the concentration of pure solid and liquid is 1. Then R. Solve this thing. You will get the reduction potential as minus of 0.509 and oxidation potential, just reverse the sign. Okay. Next question I am giving, like just screenshot this and write it in your notebooks. Maybe next question you can write on your own. Pause the video after I write the question. Find the reduction, same thing. Find the reduction potential and oxidation potential. Reduction and oxidation potential of Cr3 plus. So what is happening here? Reduction or oxidation? Cr is giving me Cr3 plus and 3 electrons. So what's happening here? It's oxidation. At 25 degrees Celsius. And E naught value of this thing is given as minus of 0.75 volt. Now it's your choice. What you need to find? You need to find the oxidation potential first or reduction potential first. That's totally dependent on you. Just be careful that both the values should be same here. Let's find the reduction potential here. We know chromium is giving, like, just see this, chromium is giving Cr3 plus. If it's 3 plus means it's losing 3 electrons, right? Now directly apply the formula. So therefore it means N will be equal to 3. And E naught value for this thing is, particularly this thing is given to you in the form of reduction potential. So we need to convert, we will be needing to convert it into oxidation potential. Because why? Because we are finding oxidation potential now. So just if we need to convert this thing, E naught Cr3 plus will be giving you plus 0.75 volt. Just substitute everything in a formula. E of cell is equals to your E naught cell minus of 0.059 by N log base 10 concentration of product by concentration of reactant. Now here you can, like, this is your main reaction, okay? Just see, your main reaction is Cr3 plus. E naught cell is already given 0.75 volt. So 0.75 volt minus of 0.059 by 2, sorry, by 3. By 3 because you have 3 electrons here. By 3 log base 10 concentration of product. What is product here? Product now here is Cr3 plus. Cr3 plus concentration is 0.1. 0.1 divided by 1. Why 1? Because it's a solid, it's a pure solid. So you can write it as 0.75 minus of 0.059 by 3 log base 10. Can I write it as 10 to the power minus 1? Same thing, minus 1 will go this side. So 0.75 minus 0.059 by 3 into minus 1. Log base 10 is 1. So I'll just write it like this. So when you solve this thing, you will be getting 0.770. That is your oxidation potential. And what will be your reduction potential? Oxidation potential is 0.770 volt and your reduction potential will be minus of 0.770 volt. This is how you find the reduction potential and oxidation potential. Just go back and see how did we find for the reduction potential also. Same thing only. Only thing is your E naught value should be in reduction potential. For that case, here the E naught value should be in oxidation potential. Now if the question comes, find this EMF of the cell. What was EMF? The difference in the electrode potential of both the cell. Find the EMF of the cell. Cr3 plus 0.1 M. So here you need to find the EMF of the cell. How do we find EMF? You remember the formula, right? E naught of cell is equals to E naught of cathode minus of E naught of anode. So here we already have found earlier, like in the last two questions, like this is a continuation of your last two questions. We already know that E of Fe2 plus and Fe was minus of 0.509, like both reduction potential I am taking, and E of Cr3 plus and Cr was minus of 0.770. Now if we want to calculate the E naught cell, what do you need to do? E of cathode minus E of anode. Which is cathode and anode? This is your anode. So minus of 0.509 minus of minus 0.770, which will be equal to your 0.261 volt. This is how you calculate the EMF of this particular cell. What did we do? Like everything was given. For E naught values of everything was given. We found the E naught value of individual things first and then combined it, right? It's very long. So what will we do is we'll try to find a shortcut of it. Like what will be the shortcut? Cr is giving you Cr3 plus 3 electrons, right? And iron was accepting 2 electron to give you Fe, right? Now can you see both here, like electrons, like there are not equal electrons. So in order to make it equal, I'll just multiply this with 2 and multiply this with 3, so that you get total of 6 electrons. So this will be 3 Cr is giving you, sorry, 2 Cr. 2 Cr is giving you 2 Cr3 plus 6 electrons, and here also you are getting 3 Fe2 plus 6 electrons is giving you Fe. Now how to write the reaction? We have already studied. 2 Cr plus 3 Fe2 plus is giving you 2 Cr3 plus Fe, right? And now find the E of cell. This concentration was 10 to the power minus 2, and here the concentration was 10 to the power minus 1. How do we find the E of cell is equals to E naught of cell minus of 0.059 by n log base 10 the concentration of product upon concentration of reactant. E naught cell we need to find. So how will we find E naught cell? E of cathode minus E naught of anode. Which one is cathode here? This one is cathode, right? Because it's undergoing reduction. So what is the E naught value of this? Already given. This thing was already given. So minus of 0.45 minus of minus 0.75 volt, which was equal to your 0.30. Now E naught we have already got. Just substitute all the values now. Now this is our main reaction. Okay, this one is our main reaction. How will we do it? E of cell will be equal to 0.30 minus of 0.059 by how many electrons are there in total? Total 6 electrons. Log base 10. Concentration of product. What is concentration of product? 10 to the power minus 1. What is the concentration of reactant? 10 to the power minus 2. So solve this equation simply. You will get the log base 10 to the power minus 1 minus of minus 2. So it will be plus 2. Log 10 to the power 1 it will come, I guess. No, minus 6. Oh, sorry. 10 to the power minus 1 raised to the power 2, right? And here it will be 10 to the power minus 3 because you have coefficients here. So Cr will have, like whatever coefficient is present, it goes on in the power. So after you solve it, it will become 10 to the power minus, I think so, 4. Yeah, 4. It will become 10 to the power 4. So same thing, 59 by 6 into 4 log base 10, which is 1. So after you solve it, you will be getting 0.26 volt, which is the same thing. We'll do one more question for the clarity of it, but you can always, go back and check again. Let's do one more question. I think this question should be more easy for us. The question is, find the EMF of the cell. What you have to do? You have to find the EMF of the cell at 25 degrees Celsius. And what is the cell? Zn2 plus. This is your 0.1 M. Sn2 plus 0.01 M and Sn. First what you do, write down the reactions. What is happening here? Zinc is getting oxidized. Zinc is getting oxidized to Zn2 plus N2 electrons. What is happening to Sn? Sn is getting reduced. So Sn2 plus 2 electrons is giving you Sn. Write the overall cell reaction. 2 electrons are getting cancelled. You are getting Zn plus Sn2 plus is giving you Zn2 plus Sn. Now we need to find the EMF of the cell, right? And there are two more things which are given. E naught of Zn2 plus and Zn is given to you as minus 0.76 volt, and E naught of your Sn2 plus and Sn is given to you as minus. So both are reduction potential only, right? So just apply the formula directly. What was the formula to find, what was the nernst equation? E cell is equals to E naught cell minus of 0.059 by N log base 10 of product and reactant. How do we find E naught cell? E naught cell is equals to E cathode minus E naught of anode. What is cathode here and what is anode? This one is your anode, this one is your cathode. So cathode is this minus of 0.14 minus of minus 0.76. So you calculated, this one will become 0.62. Just substitute it here. So this one will become 0.62 minus of 0.059 by how many electrons? 2 log base 10. What is the concentration of product? What is the product concentration? Zn. Zn is 0.1. So 0.1 divided by, no coefficient, right? So nothing on the power. Sn2 plus. Sn2 plus is 0.01. 0.01. Now I can write this as 0.62 minus of 0.059 by 2 log base of 10. Can I write it as 10 to the power minus 1, 10 to the power minus 2? Yeah. Okay, sorry, this is 0.001. Okay, 1 minute. This is 0.001. So this will be 10 to the power minus 3. Then 0.62 minus of 0.059 by 2 log base 10, 10 to the power minus 1 minus of minus 3. This one will become 10 to the power 2. So 0.62 minus of 0.059 by 2 multiplied by 2, which is equal to your 0.56 volt. So when you solve it, you will be getting 0.56 volt will be your answer. Just do this question again and again till you understand things. Let's do a similar question in a twisted manner. The question tells us find the EMF of the cell. Find the EMF of the cell. The E of cell is 0.092 volt, and this is your cell given. Platinum H2 1 bar. Sorry. H plus, which is aqueous, and 1 M is given. It's basically a hydrogen cell. M4 plus, M2 plus, and PT, sorry. This is what is given, and at 25 degrees Celsius, E naught of M4 plus and M2 plus is your 0.151 volt. The E naught of H plus and half H2. You know, like why this cell looks like this? Because guys, just 1 minute.
Hello. Hello.
Okay, so sorry for the disturbance. Yeah, so we were doing this question, right? Just write this question. Why the cell representation is quite different is because it's a hydrogen cell. We'll be doing standard hydrogen electrode in our next topic. So this is your, sorry, this is your anode, because oxidation is happening, and this side is will be your cathode. Why? Because reduction is happening. What they have given is, they have given us the values of E naught of both the things, and they have given the concentration, like the the concentrations of M2 plus and M4 plus is 10 to the power x. What we need to find? We need to find the value of x. Now, how will we find it? First, write the reaction. So, don't worry about these platinums written here. Platinum is just a reference electrodes here. Don't worry about it. Just worry about this H2, H plus, M4 plus and M2 plus. First, let us write the reaction. What is the reaction? H2 is giving you 2 electrons, 2 H plus and 2 electrons. You can write it like this also, or else you can write it like, H2 is giving you half H plus and half electron. Something like that also you can write, but to get a balanced equation, you write it like this. Then the second reaction, what is happening? M4 plus, how many electrons it is accepting? It is definitely accepting 2 electrons to give you M2 plus. Combine these equations, what will you get? H2 plus M4 plus is giving you M2 plus plus 2H plus. Now how will you write E of cell? Same things. E naught cell minus of 0.059 by N log base 10 product by reactant. How will you find E naught cell? E naught cell will be E cathode minus E anode. Which one is cathode? Which one is anode? You are already aware of it. I think enough practice is already done for this. E of cathode will be, this is your anode, this is your cathode. So E of cathode is 0.151 volt minus of 0 volt. So this will be 0.15 only, 151. So when substituting the value, 0.151 volt minus of 0.059 by N. What is your N here? 2. Log base 10. What is the product here? M2 plus. And your reactant is your M4 plus. Whatever is in the ionic form, we write it like this. And E of cell, but here is already given to us, right? That is your 0.092 volt. Now what? Basic algebra. 0.092 volt will be equal to 0.151 minus of 0.059 by 2 log base 10. Now this value is already given to us, 10 to the power x. You need to find the value of x. 10 to the power x. So this x will come in front. 0.092 volt equals to minus of 0.151, 0.059 by 2 into x. Just try to solve this thing. It's very easy. You just need to find the value of x. On solving, your answer should come as x equal to 0.052. That's what we wanted to find it out, right? So this is how you find the EMF of the cell. One last question we'll be doing. The last question is, find the EMF of concentration cell. Now what is concentration cell? It means two same things here and there. Concentration cell at 25 degrees Celsius. So what I am taking is, I am taking my silver Ag plus, salt bridge Ag plus. Now this time it's let's say it's 2. And your Ag. So first, how do you write the and anything is given to us? E naught value is not given, right? Why it is not given? First, what we do is we can write the reactions of both. Just notice it's the same things happening, like same, like same cell, same kind of cathode and anode is there. So first time what is happening, Ag is getting converted into this thing, one electron. Second time, Ag plus is accepting one electron to give you Ag. What will be the overall reaction? Ag plus Ag plus is giving you Ag plus Ag, right? But here this one will be 0.2 and this one will be your 0.1. This one will be your 2. This one will be your 2. Now the reason they have not given us E naught value, why they have not given us E naught value? Because it's the same cell. So E naught of cathode minus E naught of anode will always be 0. Will always be 0. So just substitute all the values, you'll get the answer. So when you substitute all the values, your answer should come at as 0.059 volt. Okay. So this is how you solve the Nernst equations and find the EMF of all the cells. I hope everything is clear. If you have any doubts, please do let me know. From next video, we'll be starting a standard hydrogen electrode. Thank you so much.